law of sines part 2. What's left to cover? Well, one thing, okay? SSA case. So this is the one case we didn't talk about in part 1 because, well, you'll see why. There's some ambiguity with it, okay? And then we're going to apply it a little bit. Okay, so that's going to be our plan for this part 2 of the lesson. We're going to focus on just the cases where we don't know what's happening with this triangle yet. Okay, there could be a triangle that exists. There might not be a triangle that exists. There could be 2 triangles that exist. Now it's getting crazy. Here we go. So just from prior, okay, we know that we can use ASA, AAS, and SSA. So part 1 was these 2 cases. If you had that information given to you, you can use law of sines to solve for any measurement that you need. So for today, we're going to deal with just this case right here, side A. Okay, and we're going to see what that entails. So we call it the ambiguous case, which I thought, you know what, this is cross-curricular. Fun fact, the word ambiguous is derived from the Latin, I'm going to say this wrong, I think it's just ambiguous, okay, which means shifting, or, which we're going to use this part, doubtful. How about that? A little English lesson for you, okay? So anyway, let's talk about the math part. So if we have given information, it may define a unique triangle, 2 different triangles, or no triangle. And again, we're dealing with this case here. That was the information that was given to you, okay? So you could have 1 triangle with that information, 2 triangles, or no triangle, okay? So how do we know that? Well, it depends on the length of, and let me just draw the triangle part itself. Wouldn't make sense without these values. Wow. Try that again. There we go. Okay, so it depends on the length of side A relative to the altitude, h, okay? So again, side angle, okay, so I know this guy, I know this guy, I know this guy. However, this length, there's a couple things that could happen with it. The first thing that could happen is maybe it does meet down here. It's long enough to do that. Okay, cool, I got 1 triangle. Maybe the way this is, it could either meet here or it could meet a little bit closer to the altitude here. Now I get 2 triangles. Or it might not be long enough at all. I got 0 triangles, okay? And what we typically do, especially if you're using a compass or protractor, stuff like that, we compare it to the altitude's height and see which case is actually possible, okay? So I'm gonna write the cases on the next whiteboard, and I'm going to show you how you don't have to memorize the cases. There's actually a way to do it without memorizing all of this. But still, I'm going to show you how they're stated and what they look like. So let me put it right here. So the law of sines, the ambiguous case. Okay, so here's our options. So the first one, no triangle. You have something like this. So there it is, no triangle because, well, side A is just not long enough. It's too short, okay? So that's when side A is less than the length of the hypotenuse, just not long enough. So therefore, no triangle exists. We could have one right triangle, which would look like this. And that's when the altitude and that side are a perfect match. So we have a right triangle. We could have one oblique triangle. Remember, oblique just means it's not a right triangle at all. So something like this. Okay. So that's when side A is larger than B, so it does come down to the very line of AB. Okay? Or you can have two triangles. Okay? So it looks something like this. And let's see if I can try and draw it the best I can. There we go. Okay. And this is when the altitude's height and that side is between those two measurements there. Those are our cases that could pop up with a side-side angle. Okay? Yes?
Why is there another A on the outside as well as on the inside?
Because that's my two possible triangles. It could be this guy or it could be the entire thing. So it could be this pink one, which that would be A for you, or the blue one, which is the entire thing. Now, what I'm going to do in the examples, I'm going to draw these separately. Because I think if you draw it all together, it can be a little bit tricky to see the whole thing.
So is A not the third side of the triangle? Is it just a side?
A is that, well, here's the thing, that third side is going to be created if, or if not, this comes down. So if it's too short, it's not going to, so nothing's going to exist.
Okay.
If it matches the altitude's height, it's perfect.
Yeah.
Oh, I forgot to put B there. And therefore, you only have a right triangle, one triangle possible. If it's longer than this, it's going to make more of a oblique triangle, which means there's no right angle involved. And then over here, you could have this or an acute triangle attached to it.
Why wouldn't it just form an acute triangle? Where's the oblique one coming from if A is between H and B?
Well, it just depends on the angle of C that's being formed. It also depends on the measurement of B, which we don't know in this case. So we're just saying in general, these are the two things that could happen depending on their measurements. And we'll see that with an example.
I get it.
Put it this way. This right here is something you don't need to memorize because I'll show you a way to figure out what we're dealing with. And we're going to use, well, sign to do it. Okay? So,
Alright.
let's go ahead and put it into practice. Let's try this example. And here's what I'm going to do. I'm giving spoilers, but this one's going to have one solution, okay? I'll do that so that way when you look back in your notes, you can sit there and say, okay, what did one solution look like? What did two? What did no solutions? That way you have a good guide for you, okay? So our task is to solve the triangle. And I'm giving you that side A is 220 feet. Side B is 200 feet. And angle A is 40 degrees. Okay? And you got to find the rest of the measurements. By the way, as a reminder from last lesson, the lowercase letters represent side lengths, the uppercase letters represents angles. That's typically what we use when we try to create triangles like this. Okay? Now, I would recommend drawing a picture. And here's the thing, your pictures, it might be accurate, it might not, because again, we don't know what we're dealing with here. So just drawing a generic picture doesn't harm anything, so let's do that. So let me draw a picture. Typically, I just draw it like this every single time. I draw one that isn't a right triangle. So That's an oblique triangle. And what I'm gonna do is label things. So notice they give me angle A. So whatever angle they give me, I usually put right here. And that's 40 degrees. Across from it is little a, which is 220. And then notice that we have little b. Now where do I put angle b at? Well, typically what I do is I put b here, and then little b is across from it, which is 200 feet. Okay? That creates my side-side angle case. So this must be c, and this must be little c. And again, my goal is to solve for everything. All the angles, all the sides. But I gotta keep in mind, because this is an SSA case, one of these could pop up. Okay, so how do we approach it? Well, again, it all depends on what this guy is. Okay, what's the angle that's being created? Is this long enough to even make an angle? So to do that, what I would do, just using law of sines, we'll do sine of 40 over 220. Just as a review from last time, they go together, the angle and the side across from it. Okay, equals, and then we'll do sine of b, angle b, over 200. I can't do nothing with c because I have nothing there. So there's no reason to be even using that right now. Okay, cross multiplying here. I'll put up on this part of the board. So we have 200 sine, oh, let's do this. I like to do it this way. Let's do 220 sine of b equals 200 sine of 40 degrees. Now to get sine of b by itself, I'll divide by 220. Divide by 220, not 200. Now to get b by itself, I'll take the inverse, right? Okay, so I'm gonna write it out, but I'm not gonna write it out every single time in the future. But we take the inverse of all of this stuff, which I would highly recommend. I wouldn't type that in your calculator and then do this unless you want to carry the answer forward. Just type that all at once. But make sure you type the proper numbers in there. Now, here's the deal. Angle B is going to come out to 36 degrees roughly. Okay? Now, here's where you have to figure out, is it just one triangle I have, or two, or none? First off, it's not none because we got an angle measurement. If this was undefined, then you know there's no triangle that can exist with those measurements. So we're good with that. So this can't happen, okay? If this was a right triangle, this would have came out to like 90 degrees. It didn't, so it can't be this. It's one of these two. Now let's go back to inverses for a moment. So the inverse is sine. There's two quadrants that it goes in, 1 and 4, right? If you remember that from before. Okay. So we're in quadrant 1, right? Now, is there another output value where sine is the same thing as sine of 36? It is. It's in quadrant 2, because in quadrant 2, sine's positive. So how do we find that? We take 180 minus the 36. So I'm going to put here or. B could be, to figure out where the other part where sine's the same thing, be 180 minus the 36. I don't know why I'm doing approximate. This is exact now. Okay? And by doing that, let's see, 144. So you have two options. Either angle B is 36 or 144. Now how do we know that they both work or just one works? We'll think about something for a moment. If I plug 36 in, I could find angle C by adding up, subtract from 180. If I add 36 and 40, is that above 180? No. So angle C is going to have a measurement. That's good. I plug 144 in there. Is 144 plus 40 above 180? Yeah. So that, there's no way angle C can even work. So this guy, no good. So we do not have a second triangle. We only have one triangle there. That right there is how you can tell what case you're looking at. Okay? This is going to tell you everything. So, just to recap, you find your angle, okay? Then, because again, sine is the same in quadrant 2, because it's positive there, what sine value is also giving you the same output? Just do 180 minus it. Plug both of these into here. If you get something that can't happen, then that angle can't work. You don't have that triangle that's going to happen. So 36 is good. So let's go ahead and find the rest of it. So we could find angle C. Let me just I'll put 36 here. Okay, so now we got to find C, right? So we'll add those up, subtract from 180, and we get 104 degrees. There's only one thing left, little c, I got to find. And I'm going to use law of sines to do it. So let's use the original problem stuff. So 40 goes with 220. Again, I'm just using this because that's what the problem gave me. I know that always works. Equals sine of 104 degrees over a little c. And then I can cross multiply, and then I have my final answers. So we get little c, sine of 40 degrees, equals 220, sine of 104 degrees. I'll go ahead and divide. Just like that. And I got 332 feet. Now what we could do, and this is very good practice, especially if you have two triangles, which you'll see an example of that. Let's just neatly put it in a table. So what I do is I just put like, oh, we have one triangle. These are the side lengths we found. These are the angles that we found. So I like to, because if you look, we got work everywhere. And I would like it if you did this, because then it's easier for me to grade as well. But it's just good practice writing all your answers in one spot. So let's do that. So little a they gave us already, that was 220. Little b was 200, and little c we found to be 332. Angle A they gave us, which was 40 degrees. B we determined that 36 was the only one that worked, and then we found C, which is 140 degrees. So there it is. There's my final answer. Just listing everything together. Okay. Okay. Questions so far? So what I started there, this step, every time you approach this is going to tell you how many triangles you have. Okay? So again, you don't have to necessarily memorize this whole process. Alrighty, let's try an example with a no solution. So you guys can see what that looks like. So I'll put no solution. Again, that way you can like go back in your notes to see, okay, what I'm working on, does that match what this is? Now I can tell you ahead of time when that might happen. So the inverse of sine, what's its domain? What am I allowed to plug into the inverse of sine? It's between what two numbers?
1 to 1, or negative 1 to 1.
Yeah. So if I divide everything here and get a number that's beyond that, you type in your calculator, you get something undefined, right? So that tells you that no triangle can exist with those measurements, okay? So I got a little word problem for this one. Figured why not? Let's try something different. So as shown in the figure, which I'll draw for us, a radar ship is 30 miles offshore when a large fleet of ships leaves port at an angle of 43 degrees. If the maximum range of the ship is 20 miles, will the departing fleet be detected? Okay. All right. It's actually not a bad circle. Very proud of that. Here it is. Give you a second to draw that. I would draw little ships, but I don't have room in that picture. Do it well. It looks naked without some pictures. Here we go. There's my whole army of ships. Fearless. They're not going to sink. And then the radar ship in the middle, this is its area of detection. So obviously you don't want the fleet to be detected. You want them in there, but they are leaving the port at 43 degrees. So you want to make sure, are they going to be detected? Now, noticing something here, looking at the picture, I don't have a triangle yet, okay? The way it's drawn, it's like, okay, does this side meet that side? And if it does, they're going to be detected. Okay, so that's why it's drawn like this, because we don't know necessarily. But what I would do, because especially when they give you like a picture or a figure like this, I would draw, without all this extra stuff, draw like a separate triangle with the measurements and see if it does make a triangle, okay? So here's what I'm going to do. So off to the side, I'm going to draw this. Okay, so I'm going to draw, just without all that stuff extra, I'm going to draw the triangle off to the side. Okay, now here's the deal. If this angle ends up working, okay, then, and what I mean by ends up working is like I actually get a number when I plug in the calculator. If it does, then it must connect here, which means it's right in the range of this radar ship. Very bad, okay? They're gonna get sunk. So right now I'm assuming that it does hit until I find the angle. So let's use law of sines to figure this out. So the sine of 43 degrees is gonna work with 20. And then sine of theta works with 30. Again, across they go in pairs. So multiplying, we get 20 sine of theta equals 30 sine of 43 degrees. We'll divide by 20. And then we're going to take the inverse to finish. Okay. Now again, if this does come out to be an actual angle, I know it has to hit here. Okay. So, does it work? Well, if you type in the calculator, and here's what I'm going to do. I'm going to put it over here. So I have space. But you get the inverse of sine of 1.022999754. Okay? If I just plug the fraction part in the calculator. That's above 1, isn't it?
Yeah.
That's outside my domain. So, no triangle is possible. Which is good for these guys. That means that it doesn't connect here. It's actually beyond the triangle. They're not going to get detected. Hey, they live. That's a good sign. See? The captain did good. He measured out correctly. Okay, but there's a, and by the way, I mean, getting rid of the scenario. If it was just a normal triangle and you were trying to figure this out, you're still going to do the same thing. You're going to plug this inverse in your calculator. If you didn't type this in first to see it, your calculator's going to tell you. It's going to say, hey, domain error, and you know that no triangle can exist. Okay? Questions? Okay, so we got no solution, one solution. There's only one example left. We're going to do 2 solutions, right? We're going to see what that looks like. And that's it. Let's get rid of this stuff over here. And I'll put in parentheses parentheses, this is a 2 solution. Okay? So in this case, I can actually create 2 different triangles. So let's solve the triangle. And we have B is equal to 100 feet. C is equal to 60 feet. And angle C is 28 degrees. Okay. Again, you want to draw the triangle. Let's just review how you would do that. Again, this is not an accurate triangle. This is just a picture to help us place things on there to see how to set the problem up. I've had students in the past where they literally would erase it afterwards, say that doesn't look right. I'm like, you didn't have to erase it. It's just a picture. But some people are like that. So the angle that we know is C. So I'll just put C here in the corner, put 28 degrees here. And then little c's across from it, so this is 60. Now the other thing we have is B. So again, down here I'm going to put capital B with the side that goes with it, which is across from it. Okay? And again, the reason why I do that is because I don't know, they give me 2 sides and an angle. I don't know if it connects here or not. When I solve for that angle, that's when I'm going to know if it does actually make a triangle or 2. Okay? All right. So again, the goal is to find this angle first. And, oh, this is A and little a. Forgot to label that. And I can't go after angle A anyway because there's 2 unknowns here. So realistically, even when you set this up, you don't have to memorize that part. You just know that these have to be the ones we tackle first. So sine of 28 degrees with 60 equals sine of angle B over 100. You could flip them, by the way. If you remember from the first part, law of sines is equivalent even if you flip the fractions. But I like seeing sine first in the numerator. Okay, multiplying, we get sine of angle B times 60 equals 100 times sine of 28 degrees. I'm going to skip one step just to save a little bit of space. So it'd be 100 sine of 28 degrees divided by 60, and then we're going to take the inverse to get B by itself. So I did 2 steps in one there. You can see that the calculation is simple, but the setup and how to get to that answer does take some steps. So I'm okay if you skip a couple steps. I will tell you this, please make sure you at least show me the setup, what you start with. Because if you make an error, and I don't know what you started with, like what your original looks like, it's hard for me to figure out what you did wrong and how I can help you with it. Okay, you're gonna type in the calculator. And we get B to B, 51.5 degrees. Or, again, we want to go in quadrant 2, because in quadrant 2, sine's positive, and it can give me the same output. So if I do 180 minus that, I get 128.5 degrees. So now we have a decision to make. Do both angles work? Or does only one work? In this example, this didn't work because 144 plus the angle I had already went over 180. So I know that I was good. So looking at this, if I plug 51.5 in and add it to this, is that going above 180? No. So angle A is good. I can find a triangle with that. 128.5 plus 28, it doesn't go above 180. So I'm going to have an angle A, so this one's good. Okay, so I got 2 triangles. Perfect. Here's what I would do next. I might need that board over there. I would continue the problem with this. This guy's situation, I would draw a separate triangle for, okay? So this is the second triangle. And this one I'll make it a little bit more accurate because I know what this angle is now. So this is still 28. I don't know what that 3 did. Let's see. A, B, little a, 100. So this is 128.5 degrees. Okay. So again, this is my second triangle. I'll solve that a little bit later. This triangle over here, I'm going to continue solving. So we know what this is. This is 51.5 degrees. Okay, to find angle A, I'll just add them up, subtract from 180, and we get 100.5 degrees. Okay, so the only thing left on this triangle I gotta solve for is little a, right? And then this one's fully solved. And then I'm gonna repeat the pattern over here to figure out this guy's side length. Okay, so I have a little bit of space. There we go. So let's see. Okay, so using the measurements I have up here, the only thing I got to solve is this. I'm going to use 28 and 60 because they were part of the original. There's no my calculation I'm using that could be a mistake. So we'll do sine of 28 degrees over 60 again, but this time it'll equal sine of 100.5 degrees over a little a. Okay? Yeah, I'm definitely going to get that second whiteboard. I don't like squishing things like that. But you know what? We'll still leave that picture there. I'll just put its work on that side of the board. All right, multiplying. Again, if you want to skip some steps, because you'll see the pattern. I mean, on my answer keys for the assignments, I still show the steps. That way you guys can see it. Divide both sides. And we get A to be roughly 125.7 feet. Okay? Now that's everything solved for that first triangle. So what I'm going to do is list all of its facts, just like I did on that board here. So the one triangle, I guess you could name it if you really wanted to. Call it Bob, Jim, Sarah, I don't care. And again, because the work's everywhere, it's nice just to put it all on a table so we know what the answers are to finish things out. So little a I just found, that was 125.7. Little b they gave me already, which is 100, and then little c was 60. Angle A we calculated to be 100.5 degrees. This was 51.5 degrees, and then C, which we were given, was 28 degrees. So these are solutions for one of the triangles that was created. Okay. And now for this guy. It's his turn. Now here's the good news. We could find angle A by just what? Adding those up, subtract from 180. So that's easy. So all we're going to do is find side A again, which is going to be different than this one because there was a different angle that was formed with it. Okay. So let's see. Let's find this angle A. So again, we'll add those up, subtract it from 180, and we get 23.5 degrees. And we're going to need that because it gets paired up with this guy. So we have sine of 28 degrees again with 60. And it'll equal sine of 23.5 degrees over little a. Okay. So far so good. We okay? So cross multiply again. And then we'll divide. Tape the calculator. And this one comes out to be a little bit nicer, roughly 51 feet, and rounds up to. So now I'll put up here our second triangle. Let's put all of its measurements together. Again, it's just nice to have everything in one spot. Happens a lot in math. When you start solving things, especially when you keep going further with it, like you have all this work, and sometimes it might get confusing, like to see where the errors are. I mean, you can still put boxes around it, but still, you're still searching through the whole entire thing. Little a we just found was 51. Little b, which was already given to us, that's still 100. and little c was still 60. Okay, angle A was still 28 degrees. No, it wasn't. Look at the wrong one. 23.5 degrees. See, this is what I mean. B was 128.5 degrees, and then C was 28 degrees. There we go. So those are the ambiguous cases when it comes to law of sines. So if you see a side-side angle, okay, you could have one of those situations. And again, you didn't have to memorize that little table I made up there. I was just showing you a visual as to what can happen. If you had a compass or protractor, you would definitely be finding the altitude and measuring, but again, that's more work than needed. We can actually just use our inverse properties of sine to figure out how many triangles could exist. Okay? Any questions?